Hello everyone, this is the fourth video for Chapter 6. It deals with observational learning and a little bit beyond. We have covered habituation, we have covered operant conditioning, we have covered classical conditioning, and now it's time to take a look at observational learning, which was in some ways the beginning of the end for the school of behaviorism. Let's find out why. When it comes to observational learning, we're taking a look at this. A situation where by observing the behavior of a model, we learn something. Now, we're not engaging in the behavior directly. We are not being rewarded. We're not being punished. We're not having anything act on our nervous system. We are simply learning something new by observing the behavior of some model. And a model can be a parent, a friend, a peer, a stranger, a teacher, someone on the television, pretty much any other human being or animal or what have you that you can watch and observe their behavior and their actions. This is an adaptive process. It saves us time and effort, and it's simply put, there are certain things that we would not want to learn through direct experience, trial, or error. You really don't want, for instance, to learn brain surgery through a process of operant conditioning. See, what that means is you would have to be reinforced every time you did a brain surgery well, and you would then have to be punished every time you did one badly, and that would be the only way you would actually acquire the skills needed for brain surgery. Now, the behaviorists, at least the hard-lined extreme behaviorists, believed that the only way we learned was through trial and error, operant conditioning, and classical conditioning. But those hard-line behaviorists had a very difficult time explaining things like observational learning, or the fact that when you learn a complicated skill like brain surgery, you spend a lot of time watching surgeries before you're ever allowed to do one of them. Now, if we really did learn how to perform brain surgery through trial and error, and only by trial and error, there would be a lot more people out there who have gone through brain surgery who have come out with unintentional brain damage. Same thing with flying a plane. If we only learned how to fly planes through trial and error alone, there would be quite a few crashed planes and not that many pilots. By incorporating observational learning, the ability to acquire information just by watching someone do something, we are then able to take that information and use it in a useful way, and then learn complicated skills just by observing them and then trying them out, like brain surgery or flying a plane. Now, the observational learning change in the School of Behaviorism came with a guy named Albert Bandura, a Canadian psychologist. He's very famous for the Bobo doll experiments. Now, what he did, and you can actually watch a clip of this. I have linked to a clip of Bandura's own video from the Bobo doll study that is available on Canvas on a link that's, I think, right next to the links for this. Or at least I'll set up so the Bobo doll link, the Bobo doll video link is right above the link for this specific part of the video. What he basically did is he had kids come into his lab, and he had them sit down and watch a video. And on that video, they saw an adult come into a room filled with toys. And in the middle of that room was a giant inflatable clown doll. That's the Bobo doll. And the kids watched as this adult either played calmly and quietly, or the adult picked up a hammer, a toy hammer, and then used it to beat the living tar out of the inflatable clown. The kids were then, after watching this video, allowed to go into a room that was identical to the toy room they saw in the video. And right in the middle of the room, there's the inflatable Bobo doll. Now, the kids were... remember, there are a couple variations of this experiment. I'm going to tell you about a 3-condition variation here, let me describe the 2-condition variation here real fast. So the kids who saw an adult kind of playing calmly and quietly by themselves and not doing anything strange, they sort of emulated that behavior. They didn't engage in anything really violent. But kids who saw an adult beating up the inflatable clown doll, when they're suddenly presented with this clown doll, did the exact same thing, and they were much more likely to engage in that violent behavior. Now, what I've got here on these slides is that there's a 3-condition variation of this that I want to describe as well. So we have, again, the same situation. Kids are brought into this lab, and they're going to sit down and watch TV in this office. And they're exposed to one of 3 conditions. First is what we call the aggressive model rewarded condition. Now, these are the kids who saw this video of a boy striking another boy with a baton, throwing a ball at him and dragging him around. Now, afterwards, the aggressor boy is then shown playing with toys and eating cookies. So in other words, aggressive behavior was rewarded in this condition. So that's video 1. Video 2, aggressive model punished. So they had the same video of the boy being a jerk fighting with this other kid, but this time there was a little bit of a twist at the end. Instead of getting delicious cookies for the violent behavior, the aggressor boy was beaten up by the victim. The victim rose to the challenge and fought back and completely thrashed the other boy, the one who had initiated the aggression. So what they showed then, the first condition was aggressive behavior getting rewarded. Here's the second condition, which is aggressive behavior getting punished. They had then a third condition, which was a non-aggressive model. They just showed a video of 2 of the boys, and they were playing together very calmly in the video, cooperatively. No violence, no punishment, nothing happened. Now, remember, kids were split up into one of these 3 conditions, so they only saw one of these videos depending on which condition they were put in. After they watched these videos, they were then released into the room on the unsuspecting and completely unawares Bobo dolls, and we observed what they did. Now, I always forget about the 4th control. I'm sorry, I forgot about the 4th control. In this control condition, they asked a simple question. Okay, what happens if the kids don't see any video at all? So they just, in this condition, the kids were just put in an office and just sat there for the length of the video. They weren't shown any video at all whatsoever. Okay, now let me get to the results. Finally, that for viewing the video, kids were allowed to play in the toy room, similar to the one in the video by themselves. Again, the Bobo doll was present. Well, actually, there's more than one Bobo doll. I keep forgetting about that detail, too. I always forget about the control, and I always forget about the 2 Bobo dolls. Ugh, I'm sorry, I'll move on. So there were 2 Bobo dolls there. Here's what happened. First, the children's play was observed through a 2-way mirror, and the results were really straightforward. Kids who saw aggressive behavior getting rewarded displayed significantly more total aggression and imitative action. They imitated the things that they saw in the video, and they beat the living crap out of the Bobo dolls. Kids who were in the other conditions, this includes the control condition, the cooperative play condition, and the condition where aggressive behavior was punished, showed significantly less overall aggressive behavior. Now, what this means is kids don't just watch violence and just absorb it on the television and then run out and emulate it. They pay attention to the consequences of violent action. If they see violent action punished, they are less likely to engage in that behavior. But if they see violent or aggressive behavior rewarded and glorified, they are then more likely to engage in the behavior as they observe it as a result. So here's just the additional results that I mentioned on that last slide. So the aggressive model punished condition and the non-aggressive model and the control kids were way significantly less violent. Bottom line of this set of Bobo doll studies, including this multiple condition case where we have rewards and punishments introduced, and the original variation where kids saw an adult engaging in this behavior. And the video clip that I've linked to, it actually shows the videos of the adult engaging in that behavior and then the kid emulating it. The observation here is pretty straightforward. The film models had an enormous impact on the children's behavior. The kids did not directly experience any reward or punishment. No operant conditioning took place. No classical conditioning took place. No habituation took place. They just observed what happened to somebody else and then emulated that behavior based off of what they saw. And if they saw the behavior get punished, they didn't engage in it. But if they saw the behavior get rewarded, they were more likely to engage in it. This was a bit of a puzzle for behaviorists when Bandura published these results. It was really sort of a shockwave through the scientific community. because it was evidence of learning taking place without direct reward or punishment. Bandura would then go on to propose what he called a social cognitive theory of modeling. This was kind of a coup in the school of behaviorism at that time because he was reaching out to the cognitive side of psychology, something that really hadn't been very popular because the behaviorists were so intent on focusing on observable changes to behavior and observable connections between reward and punishment. Bandura really changed the way that behaviorists approached things and made it acceptable for behaviorists to study things like cognition and modeling. Now, according to Bandura's processes, according to the social cognitive theory of modeling, a couple things need to happen in order for a model's behavior to change a kid's behavior or someone else's behavior. It doesn't have to be kids. This can be adults modeling behavior to other adults as well. First, you need to pay attention to the behavior. This has to happen. So if you have a kid who's supposed to be watching this video and he is bored, he doesn't really care, and he's sort of staring off into space and he's not paying attention to the model happening on the show or on the video that we're showing to them, they're less likely to engage in that behavior at all because they weren't paying attention to it, so it didn't enter into memory. And if it doesn't enter into memory, it's not going to influence your behavior. Next, and this is the important part, so it gets through your attention, it gets into memory, then you need to remember it. You have to retain it. If the kid forgets what they saw, they're not going to engage in behaviors that mirror it as a result. Finally, the kid needs to be able to reproduce or perform the behavior. So you need to give them the opportunity. If they're watching a video of an adult beating up a Bobo doll, well then give them the opportunity to try that behavior out. So give them the Bobo doll and see what they do. Finally, the kid needs to be motivated to engage in that behavior. If they don't want to hurt somebody and they're really dissuaded from it being violent towards the Bobo doll, they're probably not going to do it. But, if it looks like fun, they're much more likely to then run into that room screaming and start wailing on the Bobo doll. Incidentally, that's what a lot of the kids actually did in the Bandura studies. And the video clip that I've made available to you, you can see them pretty much just really viciously attack that poor inflatable clown. Now, Bandura's results have caused all kinds of controversies and has really led people to question the influence that violent media has on kids. When Bandura's results came out, parents were very concerned at the time about violence in cartoons and television shows, and how that would then change the attitudes of children towards violence after witnessing violence on television. Parents believe, or at least the beliefs about these media effects, they believe that what observing violence like this does is it decreases the concern about the suffering of the victims. It also habituates children to the sight of violence and kind of makes it a part of everyday life. And it also, of course, provides aggressive models as a result and results in the kid tending to act more aggressively. Now, this does not mean that watching a violent show or playing a violent video game is going to automatically transform a child into a violent person. Remember what we just saw about that evidence concerning violent behavior, especially if it's put into context or punished. If kids observe consequences for violent behavior, they're less likely to engage in it. But if they observe violent behavior that is just rewarded and glorified, and they don't really understand what's going on, and they don't understand that kind of behavior still has a negative impact on the person who suffers it, even though those consequences aren't necessarily shown, it can still then influence their behavior as a result. So really, when it comes to media effects of violence, I think it's particularly important to make sure that kids understand the context in which violence occurs and understand the nature of what happens to the victims of violence. Just glorifying violence probably does not do a very good job of then teaching kids the importance of what it is and the impact that it actually has on people's lives. Now, a lot of studies have come out recently trying to desperately connect video games with violence, and I can tell you pretty confidently the evidence just is not there. There are always handfuls of studies that go out and say, look, there's a correlation between playing violent video games and engaging in violent behavior. But we've debunked that issue already. Remember when I talked about correlations and causality in Chapter 2? How correlations do not at all tell you anything about cause and effect? There you go. That's one of the cases where people try to take correlations and then claim that they've proved a link between violence and video games. The evidence just isn't there. Now, there are some other techniques, I apologize. There are some other important effects that deal with observational learning that you want to be aware of. And I'm just going to mention these last few terms very, very briefly. They're touched on briefly in the textbook. First is something called vicarious learning. We've just talked about on some level. This is just learning an action that an action has consequences by watching others being either rewarded or punished. So, you see, if you were a kid and you're playing with some other kid and you watch that kid put their finger into an electrical outlet and receive a very unpleasant shock, you vicariously learn not to put your finger into an electrical outlet because it will shock you. So that's just, again, pretty straightforward example of observational learning. Now, we have observed in monkeys series of neurons called mirror neurons. We haven't seen these in humans yet, but some theorists believe that they are present. Now, mirror neurons are neurons that are activated and become really, really active when you are observing the behavior of another individual, engage in some kind of action. So the idea here is if you are watching someone engage in violent behavior, the neurons in your brain, also responsible for engaging in violent behavior, will become active as you observe this behavior take place. Now, these mirror neurons are kind of a controversial concept. They've become very popular in neuroscience, but we still have yet to see them in human subjects. We've only seen them in monkeys so far. Next, the textbook briefly talks about an idea called a meme, M-E-M-E, like an internet meme. This is where the term comes from. A meme is just a unit of cultural knowledge that functions kind of like a gene. Remember, genes are genetic material, and they're replicating, and they have this ability to replicate themselves and pass themselves down. Well, memes are ideas that function like genes or viruses in some cases, where they're able to replicate themselves and propagate themselves throughout a culture. Really, the technical definition is a meme is a unit of cultural knowledge, but really it's any piece of self-replicating or self-reproducing or self-propagating information that spreads throughout a cultural system. This is why adorable cat pictures on the internet get passed around so fast through things like Facebook or Twitter or on Reddit. Really, Reddit especially is a gigantic meme factory that works its way out into the rest of the internet. What happens there is an idea becomes popular, it's shared amongst other people think it's funny, they share it with their friends, and these internet jokes spread the same way the cold or the flu virus are going to end up getting spread through social media contact on the internet. Memes are not just jokes on the internet, though. Really, any idea can act like this as it's transmitted from one person to another. Now, when it comes to the biology of the brain and the way that it handles learning, a couple really important systems are in play here. Dopamine, that neurotransmitter that's responsible for schizophrenia or Parkinson's disease, depending on the amount. It's also important for pleasure. It's very also present in addictive behavior and also in reinforcing behavior. So when you receive a pleasing reinforcement in operant conditioning, the dopamine system is responsible for reinforcing you for that behavior. This is also very much present in addictive behavior, which becomes sort of self-reinforcing and self-sustaining if it's particularly intense. This is why addictive behaviors can be so difficult to get away from, because you're essentially taking away a very pleasing behavior from someone. Now, learning does not just occur through external behaviors and cognitions. Learning, we believe, takes place at the cellular level. Now, we've observed a process in other mammals called long-term potentiation. And what this means is as you activate sets of neurons while you're acquiring new information, the new information actually results in a physical change to the neurons, and it strengthens neural connections. What this means is neurons grow new dendrites towards each other, and this creates a greater chance that that neuron will be reactivated. So as you learn a new piece of information, the dendrites of the neurons in your brain that are active right now as you're learning about long-term potentiation are growing new dendrites towards each other. And what this will do then is when you remember long-term potentiation at a later time, the new dendrite growths make it easier for you to reactivate the neurons that are active now, and it helps you remember that actual thing. Yeah, I know that sounds kind of confusing. The textbook demystifies this a little bit, but basically, long-term potentiation is our current candidate right now for a cellular explanation of how we learn things. It's a very powerful process, and we're learning a lot more about it with new research every day. And really, that finishes up everything I have to say about Chapter 6. That's it for this chapter, and that's it for this video. I will see you next week when we talk about memory and the processes responsible for acquiring new information.